Good afternoon, everyone. Let's start the webinar. Welcome. My name is Steen Daniels. I am the president of ICTCT and based in Brussels, Belgium. I will be your host today on behalf of the steering committee of ICTCT, and most obviously a very special welcome to our speaker of the day, Professor Shalom Hakkert. A very few words about ICTCT in the hopefully unlikely situation that you don't know ICTCT yet. ICTCT stands for the International Collaboration on Theories and Concepts in Traffic Safety. It is an association of mainly researchers that has been around since 1988, so for quite a long time already. And if you want to learn more about us, please visit the website www.ictct.net, and you can register there for all the updates, announcements on oncoming events, conferences, webinars like this, and the like. Good. Before we start with the webinar, just a few words about the next conference that is still planned to be held in Berlin end of October this year. We cannot give very much final information yet. We still hope that the conference could go on in a physical way, but that will be dependent on the evolution of the health measures, obviously, and the things that will be allowed or not. We hope to come with a final decision certainly before the end of the month. What we decided already is that for sure the conference will go on, either in a physical way or in a completely online way, or in a hybrid version which combines both options. But that's still to be decided, also together with the people from DLR, the German Aerospace Centers, who are the local organizers of the conference. Just some information, some update as well on the abstract submission process. So for the abstracts that were submitted last year and that were accepted, we asked all the presenters to confirm their possibility to present their accepted paper. We also opened a call for additional abstracts. That call is closed by now, and we started the process of reviewing these abstracts as well. More information on that will also follow in the course of the next few weeks. Then already an announcement of the next webinar that will be held the 17th of September. Same time, also a Friday afternoon, and our guest at that moment will be Professor Gary Davis from the University of Minnesota, and the title of his lecture will be Graphical Models, Surrogate Endpoints, and Crash Modification Factors. I would say at the same time a very promising and a little mysterious title, so please be welcome to join us then as well for that webinar. Okay, all over to the webinar of today. Just a very short introduction of Shalom. Shalom Hakkert has been a professor at the Technion, the Israel Institute of Technology, located in Haifa in the north of Israel. And also after his retirement, he remained active in the field. He has published an impressive amount of journal papers and research reports on a wide variety of road safety topics. I would say at least as important as that, Shalom has been around at ICTCT events. He has been a long time member and friend of ICTCT. So many of the people present today have met him. and learned from him at numerous events, conferences, and workshops. And it seems obvious that Shalom is the very right person to give a lecture today on the history of transportation and road safety research. Thank you already for accepting our invitation, Shalom. Just before we start the webinar, we want to ask your collaboration to complete a small poll that should appear on your screen right now. Just one question. The results will be visible immediately after filling out, and your data, for the sake of clarity, will not be stored. Meanwhile, a few words about the practical organization of the webinar. We plan to have a lecture of around 40 minutes. Afterwards, there will be room for questions and answers. If you want to ask a question to the speaker, click on the Q&A button in Zoom below the screen in the middle. Type into the field that is available and click on send. So you can ask already in advance your question. We have learned from the past that it's not very easy for the speaker to see all sorts of questions, and certainly not to see the people who are attending the meeting all at once. So therefore we have a moderator in the session, and that is Alexei Lorishin, who is professor at Lund University in Sweden, and who will collect the questions and orally transfer them to Shalom in order to enable him to answer as many as possible of the questions that you all have for him. And we plan to end the webinar around 4 o'clock. Just one final comment. This webinar is currently already recorded and it will be made available afterwards at the website of ICTCT. Okay, and there come the results of the poll, and it appears that most of the audience has an experience of over 20 years in the domain of traffic safety, but it's very good as well to see that there are also a couple of friends among us who haven't that much experience. So certainly for them, I think this will be a very interesting talk. Over to you, Shalom.
Okay. Well, welcome everyone. Sorry for these initial problems, but I know I'm not the first one and the only one to experience them. I'm very pleased to be here today. And as you can see, the presentation will be on more or less the history of road safety research and practice and some transportation issues over the whole period of motorization, which is over 100 years by now. And of that period, I'm around for about 55 years, so it's about half the time. So I do have personal experience of a lot of the events that I'm talking about. Briefly about what I'm going to talk about, some assumptions when I say the future. It's not going to be the Asimov and Heinlein future, but it's the future of, let's say, the coming 20 to 30 years. And I'll start from the early days of motorization, talk a bit more about accident proneness, which was at some time highly fashionable. Then the issues of highway design and safety, vehicle design and safety, and then the more modern developments in the systems approach. And finally, about, which goes together with the systems approach, is sustainable safety. Going towards the end, and some summaries and conclusions. I'll talk also about what I expect to be developments in those near future years of 20 to 30 years. And we already see that now. We have a greater reliance on public transport, walking, cycling. There will be some reallocation of urban space. Then we talk about the autonomous vehicle. You can't avoid talking about autonomous vehicles these days. That would be unfashionable. But I'll talk more about the driver assistance systems. And then some issues which are still very relevant. One is driver behavior adaptation, speed management, the aging of the population, and how we can increase our effect of safety research into safety practice. As I say, one of the issues about the future is the issue of autonomous vehicles, autonomous driving mode. There's a lot of hype about this for the past at least 10 years, probably more. I'm skeptic on this issue. I was more skeptical than the majority of people who talked about it. Till recently, I noticed a trend that becomes also more skeptical. Not to say that it will not develop and will not happen, but it will take a longer time. So maybe it will be outside those 20 to 30 years that I'm talking about. But some applications of it will occur, like autonomous convoys or autonomous power transit that already exists today. Let's talk a bit about one of the issues, which is, will there be a major shift in our town planning design? In 1973, two very serious and well-known researchers, Danzig and Satie, who come from the operations research area and who invented the simplex algorithm, which made linear programming possible. They sat down and wrote a very interesting little book, Compact City, a plan for a livable urban environment. And their notion was that one can build a number of 3 to 7 very large round buildings, 1 kilometer radius each, going up to eight floors, which would house everything together, meaning housing, working, shopping, hospitals. This would be divided into strata. So there would be floors of living and then floors of the commercial activity. And the connection between these towers would be by relatively low speed 2-lane roads with a lot of bikeways and driveways that would take care of the traffic. And on top of all that, they also suggested that we do away with our normal way of working and living, but we go over to the industrial, very efficient mode of 24-hour activity. Well, I do not believe that this will come about. But as I say, there certainly will be an increase in urban density and a shift in the allocation of space away from the car towards the other more user-friendly modes. So that's on the possible shift or major shift in the way we live. Now let's look a bit about the time frames and the major sort of evolving of thinking about crashes. We say crashes, we say accidents. Accidents already has the connotation of something that cannot be avoided. Nobody is to blame, it's an accident. And that is really the way they were seen in the early years till the 1920s when cars became more and more prevalent. The focus was on building roads and building the cars, and as an inevitable byproduct, there were accidents. And the accident research really only started in the 20s, and then the focus was mostly on the accident prone, and that's how the accident proneness idea came about, which was very popular all the way through the 50s and even the 1960s. And when I started, as I say, in the late 60s, there was a lot of activity and work and research on accident proneness. We'll talk a bit about that. Even till the 60s, most researchers dealt with the crashes as monocausal. So there were the psychologists who, of course, dealt with the drivers. There were the vehicle engineers, there were the road engineers. And it was only till the 1970s, really, that we started to talk about a system approach. Later on, in the 1980s and 20s, everyone had noticed before too, that the road user is the weak link. And there was a lot of behavioral research. And since the 2000s, as I say, we went to this system approach. And we're talking about these new notions of sustainable safety, Vision Zero, and we'll come to that later on. As I say, going back to the early years, the chance phenomenon. And if we have to deal with the driver, then of course there is advertisement and public awareness, but the main focus was on accident proneness. Now I'm giving you a table of an interesting study that was done in the early 2000s by Dr. Ronnie Factor, who looked at 20 years of accident involvement of drivers in Israel during those years, 83 to 2000. And as you can see, out of a total of over 500,000 drivers involved, with more than 500,000 of crashes, sorry, 82% over those 20 years had one crash. And if we add another 75,000 drivers, 13%, we have drivers with one or two crashes in 20 years. And we certainly would not define them as accident prone. So the result of that, or my notion of that is that even if we could define accident prone drivers, and we could have measures that treat them and deal with them, then at most we would deal and take away 5% of the driving population. And that is one of the reasons why this notion has sort of fallen in disgrace. And nowadays we are less and less talking about that. What we do talk about is if we can have tests or other means to screen drivers that have the potential of having more than usual accidents, and for professional users like pilots, training of pilots, we have screening tests who send away a lot of possible good candidates, but we can afford that. For certain commercial purposes like bus drivers, train drivers, we could also have tests like that, send away a lot of good people, but take a small number of drivers who have the potential of having less or are not accident prone. For the general public, this notion is not very useful. Let's move now to the issue of designing the roads. As I show on this slide, and this is taken from work done by Ezra Hauer in the late 90s, the underlying notion of the highway engineers was that roads designed to meet current standards are as safe as they can be, and they are as safe as they should be. And as most of you know, roads are designed by, road standards are designed by committees. And as committees go, committees generally come to a compromise one way or another. Hauer gives some very interesting examples of how this occurs. One famous example of his, I'm not going into this in detail, is about the design standard for crest curve. And crest curves are designed based on assuming a stopping distance to an object. And when over the years the cars became lower, the early cars were quite high, so the eyesight was quite high, and the object designed to was quite low. When they saw this trend of cars becoming lower, the eyesight becoming lower, they just raised the object. So this was not based on research. And we happily moved away from that now in the years 2000 and on. We have a lot of research. We have the road safety manual developed by Elvik. We have the highway safety manual in the United States. PRC has road safety manuals which pull together research from a lot of different areas. So we now can base our conclusions more and more on research, but still there is a lot of research missing. On vehicles, also the vehicle engineers had the notion till the years 1970s, I would say, that we know what we are doing and just leave us alone and we'll do what we know how to do best. And Charles Wilson in 1952, the head of General Motors, basically said what is good for the country is good for General Motors and vice versa. Then in the 60s, there were two main developments which really set the whole world on a new course. First of all, Ralph Nader did some research work on two popular American cars, the General Motors Corvair, which had a rear engine, and Ford Pinto, which was a compact car. And he showed that these cars, under certain conditions, were very unsafe. And this led to court cases, legal issues. He published a book about it, made a lot of noise. As a result of that noise, the Corvair really stopped being in production because people weren't buying it. The court cases fizzled out in the end, but it created a lot of public attention. And at the same time, William Haddon, who was an epidemiologist, he was, I think, the chief medical officer of the state of Massachusetts, and he set up the National Highway Transportation Safety Administration in 1966, which started to develop and issue safety standards that were compulsory for the United States. And of course, that pulled the whole world into the direction of more and more safety standards. And Europe quickly followed on that. And that's how we nowadays have much and much safer cars. This is a little anecdote, really. It's not really central to the presentation, but in the 1920s, you can see that there was it was said there was a sort of conspiracy by the car manufacturers and the oil industry to get rid of the streetcars, the trams in the United States. And as you can say, that worked. because General Motors at that time set up a company and bought out a lot of the streetcar companies. They were all private companies, and they all had financial problems of maintaining their public. And as you can see, number of streetcars decreased from 1970 from 73,000 to 1948 to 18,000. The number of trips decreased. It wasn't really a conspiracy, as it was later pointed out by this Paul Mays in 2010, but it was the circumstances. Suburbia, private companies, they couldn't keep up with the financial needs to invest in their tram lines. And recently, over the past 10, 20 years, we see some revival in streetcars, in trams in the United States. And of course, in Europe and other countries, they never went away. But it's more of an anecdote. It's not central to the presentation of road safety research. What is central is that during all these years, especially the 60s, the 70s, and I would say even the 80s, the vehicle manufacturers, the car industry, worked against road safety. And their issue was safety doesn't sell. And all this time they went for design issues and colors and performance, of course, still today. And they really worked against issues like the seat belts. There was a physician, a Dutch physician, Van Vaassen, in the 60s, who complained about the damage that could be caused by 3-point seat belts. And therefore, the Netherlands were one of the latest countries to implement universal use of seat belts. Automatic seatbelt systems that were introduced and suggested to the car manufacturers, they put them aside. They didn't want to buy outside the company, and they didn't believe in them. There was a lot of opposition. Airbags, invented in 1951. Volvo had, Volvo, I'm not sure. But I remember in 1979, I was driving a 1973 General Motors model that had airbags in it. And it took till really the 2000s till they were made compulsory. And the same goes for the center high-mounted rear brake lights. There were major studies by Daimler-Benz that proved that they were unsafe and they caused accidents. And again, it was only after the NHTSA intervened and did a major study. Canada was the first one to introduce them. And then finally, now they are compulsory on every car. So initially there was a lot of opposition. And nowadays, of course, the trend has completely reversed or changed. And now safety is a big issue. And together with fuel efficiency and air quality, road safety is now the NCAP, Euro NCAP, US NCAP, all the NCAPs. Give the cars the stars, and everyone wants to have a 5-star car. So now safety finally is a major positive selling point, and the automotive industry is now participating and collaborating. And that's a very good issue. In the 70s, as I say, William Haddon, 1966, he started his work. He wrote a very influential book. And he came along with this notion from analyzing the crash event in 3 phases. There's the pre-event, the event, the post-event. And there are that's from epidemiology, the host, the agents, and the physical environment. An example of that we can see here on the next slide. We have the crash and the post-crash, human factors, vehicle factors, and environmental factors. And each researcher can really take one of the squares and work on whatever is relevant for him and try and produce an improved safety climate. He took his notions from the industrial safety thinking, where in factories you don't blame, you can blame the drivers, the workers, but you don't go and think what you can do just to make them safer by blaming them and punishing them. But if people are slipping on a slippery floor, you go and improve the friction of that floor. If people cut their fingers in presses, then you invent a system that they can't put their fingers under the press, under the knife of the press, and have the fingers cut off, or the same for saws and other things. So you think about the whole thing as a system. And this system thinking is with us till today. And then, of course, we move into the 2000s. And more or less simultaneously, we got a number of countries, not a large number of countries. We got the Dutch approach with sustainable safety, the Swedish approach, which is the most advanced, I would think at that time, of Vision Zero, and the Australian Safe System approach. And they all three go together with quantitative targets, national road safety plans, action at a worldwide scale, the EU or the United Nations. Great Britain is the exception. Although they have a very safe system and they have a very good road safety record and road safety research record, they really did not adopt any one of these three approaches. And I don't know even today where exactly they stand. But as I say, they basically have a safe system. I participated in a study in an OECD group, ITF forum, that issued a report on zero road deaths and serious injury leading to a paradigm shift to a safe system. I was one of the participants and wrote one of the chapters, and I take some of the issues here that we dealt with. So this was really about how to implement the safe system approach. And as you can see here, this is a major shift. Here you can see in the center, you see the vulnerable, the pedestrians, the children, the bicycles, the motorcycles. And we first of all have to think on how we can protect them. And to protect them, we have to think about environments where cars interact with pedestrians. We should limit the speed to around 30 kilometers an hour, because at those speeds, crashes are survivable. If we talk about head-on crashes, which means the two-lane undivided highways, where we experience head-on crashes, then those speeds should not be above 70 kilometers an hour, because with seatbelts and airbags and all the crashworthiness factors built into cars, at those speeds, the crashes are survivable. If we talk about intersections, and if they are at grade, then the speed should be 50. So all this leads to the thinking that we have more or less nowadays in place, and people are starting to accept that this is going to be the norm. It's still far away from what we have in practice, what exists on the roads. And of course, on the roads, we have intersections with higher speeds. We do have a lot of areas where we do not have the 30 kilometers per hour restraint. But if you follow the last few years, and even the latest declaration of the United Nations Conference Global Safety Forum, this is the direction that things are going to. And the four principles of the safe system, which is we accept that people make mistakes that can lead to crashes. The human body has a limited physical ability to absorb those crashes. We therefore share, that means the road, the politicians, politicians, the managers, the designers, we share a responsibility to design, build, manage, and use the roads in such a way that we prevent the serious crashes. And if we cannot do then parts of the systems must be strengthened so that in total we achieve that goal of zero serious crashes or fatal crashes. And this again, this is the paradigm shift that occurred in this safe system approach, Vision Zero, that we move away from blaming the driver. I mean, the driver makes mistakes. He makes some mistakes intentionally, some unintentionally. But how do we build an infrastructure or a system in which those drivers, even if they do make mistakes, they can still survive? And how do we mitigate the crashes? I give some examples of the most prevalent crashes that exist. One is the head-on crashes, where we say safe impact speed is not over 70 kilometers an hour. And we can achieve that through, again, not through advertisement and not through propaganda, not through safety campaigns, which may have some effect, but I don't believe in them too much. But we do that through physical adaptation of the system by having median barriers to eliminate head-on crashes. Sweden started, and it is now working in a lot of countries, the 2+1 idea of dividing the road space. We, of course, introduce electronic stability control, lane departure warning systems, speed management. We still need policing. And of course, I'll come to that. We have also now the new driver assistance systems. Intersection crashes, well, first we have to understand them better. But if we understand that crashes are a combination of speed and angle of impact, then we get to the notion of roundabouts, which exist, of course, for many, many years, but some countries till fairly recently were dead against introduction of roundabouts. Now, I remember even one of the professors I worked with in Germany who claimed that the priority rule for roundabouts, which now is universal, cannot exist in Germany because it's against the law. In the United States, there was a lot of action against the introduction of roundabouts. They more relied on the four-way stop. And we have the raised platforms which reduce speed at intersections. Pedestrian and cyclists, here we have to come up with very, I would say, more innovative approaches. There is, of course, the shared zone and the pedestrian zone and the woonerf, the Dutch invention. Segregated facilities work up to a point, but they're not really the solution. So we really have to reduce speeds in areas where pedestrians are on foot. We cannot have them together with high-speed traffic. One issue which is still a major problem, and it's not going away, but it's probably increasing, is what happens to power two-wheelers, the motorcycles. There are a few countries, especially in the Far East, that have segregated lanes, but this is certainly not prevalent in most countries. There is some possible improvement to the safety of the motorcycle and the scooter. Of course, for the small-sized engines of the scooters and small mopeds, we can have segregated lanes. We can add them to the bicycle lanes, although in the Netherlands there is a lot of controversy about it, and I don't think they're in favor of that idea. And of course, there is the vehicle and rider protection, but still, it's an issue that is not really solved. Now, a few words about the autonomous cars. I said initially I was skeptical. Nowadays, I'm still somewhat skeptical about the time frame over which they will be introduced. And as you can see on this slide from some data from the IHS Automotive, it's an automotive group. They had an estimate that by 2035, 12 million vehicles would be autonomous. Now, 12 million vehicles out of the total fleet, it's about 3% of the cars. So by 2030, and I would now say even by 2035, I don't think they will be a major part of the general car fleet. It will possibly be different for the taxis and for trucks, but it will take a much longer time. And it will take a longer time because in the mixed environment of non-autonomous and autonomous vehicles, the technology does not exist yet for the autonomous vehicles to cope with all the crazy things that drivers can do and will continue to do. I watched a week or two ago a webinar on autonomous experiments in the Netherlands, where they have little shuttles driving through a variety of environments, some industrial areas, some routes to train station. They were driving around at speeds of about 12 kilometers an hour. And every time they incurred an unexplainable situation, they would stop. Now, this, of course, is not a situation that we can live with in practical traffic. So I would say autonomous vehicles are still quite far away. But what is happening more and more, and that is really coming along at a very fast pace, is the driver assistance systems. And we now have the electronic stability control, which is compulsory on all vehicles. And we get more and more driver assistance systems that are coming in. And recently, the European Union has taken some decisions on making these systems compulsory from 2022. And they should be introduced compulsory in the fleet by 2024. So this, and I'll say a bit more about it, but I think later. And one of the risks of the self-driving cars, the autonomous cars, is that it will take attention and funds away from the real practical developments in driver assistance systems, which are necessary and positive, to the notion of the autonomous vehicle. So again, we talked a bit about the time frame. I said 30 to 50 years. 50, I think, is a bit far away. There will be a gradual implementation of autonomous driving. I think first in experimental areas, perhaps some parts of cities. In terms of town planning, I think we will see ever increasing densities of our cities, because that is most efficient and that can cope with public transport, and that will to some extent do away with the suburbia or the spread of suburbia and the low density areas, so that we can move away from the car. So that will also result in a reallocation of road space. Reallocation, I mean taking space away from the private motor car and giving more space to the bicycle and the pedestrian. And I see now in a number of papers and conferences, people are starting to talk about the 15-minute city, meaning the 15-minute city, which is a city in which every activity can be reached within 15 minutes, but not by car, but by other more user-friendly means. There will be, leading from this or going with it, there will be greater reliance on public transport, walking, cycling. All this will have implications for road safety and road safety research. And therefore it should be accompanied by up-to-date research that assesses all these shifts. More and more bicycles on the road doesn't necessarily mean more and more safety, but we have to see how we can cope with systems that have both or all uses of transport. And another issue which I think needs more analysis is to deal with the door-to-door trip. We leave home, we take perhaps a scooter or a bicycle, we go by train, then we take a scooter again, and then we do some walking. And each mode has its own risk assessment, and we should look at the door-to-door trip. I mentioned the introduction of driver assistance systems. They should be accompanied by independent evaluation. Until now, in many of the issues, there is resistance from the companies. Once they invented something, developed something, there is resistance to have it independently evaluated. And that's a role of research institutes, who of course need the funds, and governments. We have in Israel a very large company, Mobileye, who was bought up for an enormous sum of money by, I think, Intel. And they, in their early years of development, they consistently resisted doing independent research outside their own company. Perhaps it has changed recently. Of course, in the United States and other countries, we have naturalistic driving studies, which are important because that is observing what drivers do in real life situations. I talked about the driver assistance systems, but I mentioned here also the in-vehicle data recorders, which are a very useful tool for registering what drivers do. And then, of course, there is the driver assistance of lane departure warning, returning to the lane, automatic distance warning, and automatic braking. All these systems have great positive impacts on safety and should be evaluated. There are also systems which have negative effects on safety, like navigation systems, mobile phones, and in-vehicle information systems, and that should also be evaluated. A few words on driver adaptation. We were, over many, many years, we were fairly simplistic in our thinking that if we do something that improves safety, then that's what it does. Then came along in 1994, Jerry Wilde with his risk homeostasis notion that there is a certain level of risk for each driver or even each society that we try to keep constant, meaning that if there is something that takes some risk away, then we will compensate for that to get back to the same risk. Well, that notion has been more or less, I'd say, proven to be not to be so. But what goes with it is that there certainly is adaptation. And if we introduce a measure that possibly or probably improves safety, then there will be some adaptation. And the one who has done quite a lot of research on that is Dr. Alison Smiley. And she did research on edge line markings on curves and showed that if we have high visibility edge line markings, speeds go up. It doesn't necessarily mean that there will be no positive safety effect, but less than what we expected. For intersection red light cameras, there will be some effects of rear-end collisions where drivers are not in the same mode of thinking. And we in Israel have a certain unfortunate issue with blinking green, as has Austria and a number of Far Eastern and East European countries. The last area, yes, I'm coming to the end. I have a personal policeman watching over the time limit. My wife, she tells me that I'm getting to the end and have to hurry up. The last issue, which to my mind is not solved yet, is how do we get drivers to maintain the speeds that we would want them to keep? And of course, we cannot rely only on enforcement, and there is automatic enforcement, and there is section control, but we have to have better means. And I think we are now getting to the stage where we are where we are seeing the intention to adopt intelligent speed adapters, meaning that the vehicle technology will let the vehicles drive at the speed limits to which authorities think they should drive. And this is a very recent trend. The latest European programs are taking this into account. It wasn't there before. I won't go into very detail because I want to leave some time for questions. But issues that we have to deal with, aging of the population, older people have slower reaction times, see less well, and we have to redesign our road infrastructure to take that into account. There is the issue of the scooters and the individualized public transport, which may or may not be more frequent. And finally, I'd say, if we could better cooperate with the health and environment professionals, they have vastly higher public funds available than the road safety research area. And we are all three are leading to the same, leading in the same direction. That better safety or better safety, more use of walking and cycling has better environmental effects, health effects. If we can get these three to work together, there will be more money for research and we will probably be more effective. And of course, also some more research on decision-making. I'll leave that out. And that's about more or less what I wanted to say. So thank you very much. One last point, this presentation and also the paper on which it was based were prepared together with my colleague, Dr. Victoria Gittelman. We are both on the paper as authors on which this was based. So if you want to know more, then there is that. Thank you.
Thank you, Shalom, and thanks to your wife as well to keeping a bit an eye on the timing. And I guess you asked her on beforehand to keep that eye. So let's move on to the Q&A session. And for that, I would like to hand over to Alexei.
We have a question here from Jürgen Gerlach, who is asking you, Shalom, what would you say? Are we living now in the peak period of regarding road safety issues? Is the weight of safety issues in decisions higher than ever before? And if it is so on, will the development go on? Should we do more?
Okay, well, thank you, Jürgen. Nice to know that you're participating. I'm not sure that there is more safety research activity nowadays. My impression is the opposite. There are quite a few countries where, including my own, where funding of road safety research has gone down quite a lot. The EU research program, also, I think, 10 years ago, there was a lot of emphasis and there were a lot of funds in road safety research. And I think that has gone down. What has, of course, improved tremendously is the involvement of the technology side and the vehicle side in developing all these new driver assistance systems. There is a tremendous amount of money involved, and that has improved. But I would very much like to see that accompanied by a similar increase in independent evaluation of all these systems. That's it.
Yeah. Okay, thank you. I don't know, there are no more questions from the audience, but I have a question. You've been talking mostly about the Western countries, like the rich countries where automobilization started quite early, so we have 100 of years of history together with cars. But what would you say about the developing countries? I mean, if you look at situation in Africa or in Asia, how to solve problems there?
Well, I have positive news and negative news. Of course, the developing countries could learn a tremendous amount of all the mistakes that have been done over the years in the developed world. And this especially about the increasing use of the private cars and more road space, more reliance on cars and the suburbia and everything that goes with it. And now we have, over the past 10, 20 years, we have this shift in thinking. That's the positive side. Negative side is, some of you may know a professor in road safety from India, Dinesh Mohan, who passed away last week. And he has also been involved in road safety for almost as long as I've been involved. And I met him some years ago, and we had discussions on this issue. And I tried to convince him of this way of thinking, that they should now start thinking of having a more balanced system of less reliance on private motor cars and more reliance on other vulnerable road user modes. And his response was that, leave it to us. We know what we are doing, and everything is fine. So I'm positive and negative. If they're willing to learn from all the experiences of the developed world and the mistakes made there, then they can save a lot of pain and injury and go towards a more balanced road system. If they don't, then they'll go through the same phases. And in fact, you do see that road safety in the developed world over the past 20 years has improved tremendously and has more than halved the number of fatalities. But in the developing world, they're still going through the phase of increase in fatalities and serious injury, and they'll do all the mistakes that we have done. So positive and negative.
Okay, thank you so much. I have also a question from Charlotte Bugs. She writes that she is particularly interested in road safety implementation. So the question is, what type of research on road safety management would be especially useful?
Well, hello, Charlotte. Still with SWOF. I would say that as far as the implementation goes, we see some very positive movements over the past, I would say, 10 years. First of all, there is the OECD that adopted and talks about it and issued a report. And then their government, and on the at least the European level, but also in the United States and Australia, New Zealand, we see thinking about how to implement. And as I mentioned at the beginning, there are these activities in the EU nowadays. First went through Parliament, now it goes to the Commission, of adopting a more balanced transportation system that leads to, I would think, that leads to more safety, and especially the focus the last few years, I would say, on reduced speeds will help tremendously in getting more safety. So initially we just had the 30-kilometer traffic calming measures in residential areas. Then some countries more, some countries less, expanded that to more and more parts of the city. And now we are getting into the phase of talking about intelligent driver assistance, so limiting speeds to the speed limits. I think in that, and of course research should accompany all these actions, so that governments don't go to sleep and move to another area of interest at that particular moment in time, but to show that this is really the way forward.
Okay, thank you so much. Just one more question popped up. How are we doing with time, Steen?
Yes, I think we still have time for a question.
Yeah, I have a comment here from Matsoki Belin from Sweden that implementation of safety, it has been identified as a very important issue, and we actually have an entire research program running on that.
Okay.
Yep. It's a question from Ruth Bergel-Hayat regarding how should we prioritize the funding for road safety research. What would you suggest?
Oh, that's
and
very...
if there are a difference also between Europe and outside world?
Well, let's start from the second part. I think funding should go hand in hand with the issues in a particular area or country. So, and this obviously makes a difference between developing countries, which have a lot more cycle traffic and rickshaw traffic and pedestrian traffic, than developing worlds where in the United States, pedestrians are not very central to their activities, for instance. So that makes it important to shift the attention. Some countries will focus on one thing, some other countries on another thing which is relevant to their environment. As far as how do we prioritize, that is difficult to answer. The easy answer is you do a cost-benefit analysis. But cost-benefit analysis have a lot of limitations, and they don't always come up with the right answers. So I think you should focus on something which is important and central. For instance, I'll give an example. In the distribution of traffic accidents, Israel has a very high proportion of pedestrian accidents. In fact, Israel and Great Britain have the highest proportions in the ERTA database of pedestrian accidents. As opposed, for instance, the Netherlands, Belgium, Denmark, Germany to some extent, have a very high proportion of cycle accidents. So obviously, in those countries, you do a lot of cycle research. In Israel, you should do a lot of pedestrian-focused research to find out what you can do to create countermeasures that come up with some solutions. And that is just one illustration. And the same would apply to the type of vehicle. In some countries, you have a high proportion of motorcycles. You pay, or cycles, you pay more attention to those. In other countries, you have very few of those, less focus. That's my approach.
Yeah, thank you so much. I think we should round up, but Sten, you have the very final question, and you have also the microphone.
Okay, then I will ask the final question. How do you think, Shalom, can there be an impact of the current COVID-19 situation on road safety? I mean, very many people, citizens as well as decision makers have seen now that in fact the number of road crashes can quite drastically decrease if traffic becomes completely different, if exposure decreases in fact. Do you think it can have some longer term consequences?
Well, I think it will have consequences, but less strong than many expected. So initially, when COVID came along and we had the lockdowns, the amount of traffic decreased tremendously. Initially, people were very happy and said, oh, we'll have fewer accidents and fatalities. Then it turned out, as you say, that speeds went up because the roads were less congested. Now we are in a phase where in some countries, and Israel among them, we are almost past COVID. Not really, but it's very at a very low intensity. Amounts of traffic have gone back to what they were before. What I think will happen is we will see some lasting trends in home working, which means we will have less home to work trips. But in terms of traffic on the road, I think we'll be very quickly be back to what was before. And the main issue will again be congestion on the one side and speeds on the other side. Congestion is good for safety in a way, because it is low speed and it's difficult to create a fatal accident at speeds of 15 to 20, 30 kilometers an hour. But speeds, if they go up again, then we should deal with that issue. So the answer is mixed.
Okay, thank you. Thanks a lot, Shalom, for being here and sharing your insights today. I think this was very interesting, both for the ones that were quite new in the field, but also for the ones that have been around for many years. It's always good to see things in a well-structured way and to get updated about a few evolutions. So thank you for that. Thank you as well for all the people attending the session today. Hope to meet you in person as soon as possible. Meanwhile, keep safe and keep healthy and enjoy the rest of the day and hopefully the weekend. Thank you. Bye-bye.
Thank you all.
Bye.